I think we might get started. Kerry, welcome everyone. Welcome to session 2. Thank you all for attending. For those who weren't here last session, I'll just do a quick introduction. So, my name is Carl Chua. I'm an engineer with the National Heavy Vehicle Regulator. Been here for about 5 years, doing notices, permits, vehicle assessments. This session is about the bridge formula and the mass exceptions through the HVNL. If there are any questions, feel free to submit them. If they do relate to a certain slide, just put the slide number down. This session will also be recorded, so I'll be able to send out the presentation recording after. I'll pass it on to Kerry now, who will introduce himself and start the presentation.
Yeah, first of all, with regard questions, we'll probably look at them at the end of the presentation, so we've allowed time there to go through all the questions submitted. But apart from that, my name's Kerry Plater, Principal Engineer with the NHVR. I've been here about 8 years, got about 40 years engineering experience, probably over 30 of that to do with heavy vehicles, earth movement, machinery, some road building experience as well. So that's me. And so webinar topics, we're on topic number 2. This is 9 sessions we're looking at. So they're general high-level information to help you understand your roles and also different parts of the law, of the Heavy Vehicle National Law, and also how we can help you with, assist you in your role as local road managers. So the contents, what we'll do, we'll go through the axle mass spacing requirements. We'll go to other MDL or mass dimensional loading regulation requirements. We'll look at mass exceptions. We'll look at how the PBS or performance-based standard bridge loading is applied and the different tiers on that, and then we'll have questions after that. Okay. There's a thing called Axle Spacing Mass Schedule, or ASAMMS. Now that's actually came out of a Austroads review in '94, which is called the Austroads Review of Axle Spacing Mass Schedule for General Access and Restricted Access Vehicles, AP 11394. What happened when they did that review? Prior to that review, each individual state had some axle spacing formula, but they only applied to gross vehicle mass, so they only looked at the total mass of the vehicles. With this new formula that was developed, they actually looked at the internal spacings and the internal groupings of axles as well. So, and that they were approved by the state ministers, and they were adopted by the states into legislation in the mid-90s, and they were rolled over into the HVNL, or the Heavy Vehicle National Law, when the National Heavy Vehicle Regulator came into play in 2014. So if you look at the use of those, now they're also used in performance-based standards. They use these formulas, and they use the formula directly, where the mass dimensional loading regs has tables. Now that's an example of table 2 shown there, which is for general access vehicles. There's also tables for B doubles, table 3, and table 4, which is for road trains. So the intent of these, or the reason why they're in a tabular form in the regulations, is explained in the statement of this 1994 paper review, which was highlighted there in yellow. It says, while using a formula approach is practical in the design stage of the vehicle, so they were designed to allow you to build a vehicle, get its axle spacings right and the masses you're going to use on it, so that it could have network access, either general access, the B double network, or the road train network. So it goes on to say there were significant disadvantages for operational and enforcement purposes. So this is back in 1994. where while quantum computer and calculators can overcome these infield problems, their availability and the competence to use them by some operators are still limited. So they thought it was better to have tables in the law so the enforcement basically could be able to enforce it on the side of the road. So it's the only reason it's in tabular form in the law, and it's never changed since then, despite improvements in usage and availability of computers and calculators. So you can use your phone here or work it out if you wanted to. So that's why it's in a tabular form, but both the performance-based standards, axle spacing mass schedule, and the ones in the law are from the same formula, and the performance-based standard ones are empowered by the HVNL, so they're actually like a legal requirement as well. Next. So if we look at general access, the first table is a general access, so it goes to a maximum of 50 tonne. It's equivalent to the PBS route classification level 1. And the bridge formula has 2 stages. If your total mass is less than or equal to 42.5 tonne, the formula is the mass allowed is 3 times L, and L is the minimum distance between the extreme axles of any combination of axle groups for a given total mass M. So we'll go through some worked examples of how this works. So that's MDL, or the mass dimensional loading regulations, Schedule 1, Table 2. Once your total mass is over 42.5 tonne, the formula then changes, which is shown by the change in slope of the line down there in the graph. And you then use M equals length, L, plus 32.5. Now, that is now in the MDL schedule table 2, greater than 42.5 tonne. It was actually extended recently with the inclusion of twin steer prime movers in the regulations, so they go up to 46.5 tonne. The National Class 2B double notice for general access follows the same formula, so it allows up to 50 tonne, and the National Class 3 truck and dog notice has that table, has that in tabular form as well, so they're all in tabular form. So if you look at the different ones, the green there is the MDL, and there's a bit of a glitch at the front because of the tabular form where it actually allows you more weight at a lower distance, but that's how how it was put together. The PBS is the purple line, up to 42.5 tonne, follows exactly the same line. The 50 tonne truck and dog and the B double notice, it's the dotted line, and for over 42.5 tonne, and PBS level 1 for over 42.5 tonne follows the exact same line and levels out at 50 tonnes. With these graphs, the maximum point of it is the maximum you can get with that combination. So it's got to do with the maximum extreme axle space, and giving that if your vehicle is a certain length, and normally wheels are about 1 metre in diameter, if you've got a 20 metre long vehicle or a 90 metre, let's say, if you've got a 19 metre long vehicle, the maximum axle spacing from the first axle to the last axle cannot physically be longer than about 17 metres. So even though these tables extend, the extreme axle spacing is not the full length of the vehicle, which we'll look at later. Next. So the next one is B double network. So this for access to the B double network, and all these, I don't know, I said before, the actual formulas reflect more vehicle design. They're not actually a bridge formula or a bridge design characteristics. They're actually a vehicle design requirement. So for a B-double network, which is level 2 PBS, tier 1, so we'll talk about the tiers in PBS for bridges. And the bridge formula for that is up to 46.5 tonne, 3L plus 12.5, which is the same as for general access, except it goes slightly further to 46.5. After 46.5 tonnes, it's the allowable mass equals 1.5 times your length plus 29.5. So that's again shown by the change in slope. So in the mass dimensional loading regs, it's Schedule 1, it's Table 3, which is a B-double table. The B-double table is tabular. It goes up to 62.5 tonne, and it's got actually a little kink right at the end at 62.5 tonne to get 62.5 tonne in. If you look at the PBS level 2, follows the same line up to 62.5 tonne. It can go slightly higher. So under PBS level 2A, you can probably go with a 24 metre extreme axle spacing. You can actually go up to about 65.5 tonne under those tables. And PBS level 2B, which allows a 30 metre vehicle. If you've got a 28 metre extreme axle spacing, you go up to about 71.5 tonne using that, but it has exactly the same slope. But because of the longer length, you can get a longer, you get a total mass slightly higher. We go on to the next one, and this is the road train one, and it covers both level 3 and level 4 PBS. And level 3 is equal to your 36.5 metre road train. Level 4 is equal to the 53.5 metre road train. So the bridge formula for this is 3L plus 12.5, but it's basically for all dimensions. And it's in the mass dimension and loading Schedule 1, Table 4. So if you look at the same requires MDL under your notices and the PBS. Now, if vehicles want to operate as a road train under the law, they have to meet these axle mass spacing requirements, otherwise they're not a road train under the law. So if you've got very close spaced axles, they're not actually a road train. So that's something to consider. With the mass dimensional loading regs, it caps out at 172.5 tonne at 53.3 metres overall axle spacing. PBS 3A, which is a maximum of 36.5 metres long, it maxes out at about 116 tonne. 3B, which is up to 42 metres long, maxes out about 132.5. 4A, which is 53.5 metres long, you max out at about 167, which is under the cap for the actual MDL. And if you go to a 4B, which PBS vehicle, which could be up to 60 metres long, you can possibly go up to about 186.5 tonne maximum gross mass for that combination. So I know we've got tables and tables, but we'll go on to how we actually use it in the next slide. So axle spacing mass limits, this is actually taken directly out of the mass dimension and loading regs, the part on the left. So it says conforming vehicles must have at least the minimum axle group spacing. The below diagram shows the measurement points to determine mass limits axle spacing of a heavy vehicle, including the distance from the centre line of a single axle to the centre line of a double axle, distance from the centre line of a single axle to the centre line of the furthest axle in any axle group, greatest distance between the centre lines of axles in any two axle groups. So if you look at on the left there, the top thing, it's a prime mover semi-trailer. So single steer, tandem drive, triaxle. So basically the best way to do it, you say you go axle 1 to axle group 1, start of axle group 1 to the end of axle group 2, which is that blue line, the top blue line. Then you go axle 1 to the end of axle group 3, which is the overall distance. And then you go axle group 2 to axle group 3 in this case. In the following example, you go extreme distance, axle group 1, axle group 2, axle group 1 to axle group 3, and then axle group 1 to axle group 4. And then you go axle group 2 to axle group 3, axle group 2 to axle group 4, and then axle group 3 to axle group 4. So on the right hand side there's actually a worked example showing you minimum distances based on your weights, and that's for a 26 metre restricted access B double. So we're using table number 3 and the formula that says 3 plus 12.5 up to 46.5 tonne and over 46.5 tonne L plus 29.5. By using that, the distance from axle group 1 to axle group, from the first to the third axle, so axle group 1 to axle group 2 up there, there's actually a requirement in the law that you've got to have a minimum of 2.5 between axles, and then you've got to have at least 1 metre on a distance on a tandem axle group, so that has a minimum of 3.5, even though the tables say 2.5. So there's other parts of the law that control dimensions and axle spacing. So if you're 6 tonne on the steer, 16.5 on the drive, and whenever you do your axle spacing calculations, you use GML limits, so it's your general mass limits, including, and don't include a complying steer axle, so they're always 6 for a steer axle, 16.5 for a 4-tie tandem axle, 20 tonne for a triaxle group fitted with 4 tyres. So that's and you work it out, and that's what they usually use. So I've got 3.5 minimum there. So we'll go axle 1, we'll go 1 to 3 next, which is down there. So axle group 1 to axle group 3, you have a total mass of 42.5 tonne. You mean a minimum distance of 10 metres to meet the B double requirements. Then you do axle group 1 to axle group 4. So we've done 1 to 2, 1 to 3, 1 to 4. And so you've got a total of 62.5 tonne. So you need a minimum of 21 metres to meet the requirements. Okay, so then you look at axle group 2 to axle group 3, which you've got 16.5 and 20 tonne is 36.5 tonne. So you have an 8 metre minimum there. And then if you look at axle group 2 to axle group 4, you've got a 56.5 tonne there. So you need a minimum of 18 metres to be a complying B double.
And just to clarify, so the B double example we have up here, let's just take axle group 2 and 3 for example. So it's 16.5 here and 20 tonne. So the total mass we're after is 36.5 tonne. So this is a 26 metre B double. So we'd look at the B double table in the regulation and see what the minimum distance required is for 36.5 tonne, and that's where we get the 8 metres from. So the 8 metres would be from the table based on the mass, the GML mass of that axle group, and you'd apply that over
every combination of axle group.
As for the diagram on the left. So similar to the rear trailer, we're looking at 40 tonne for the 2 triaxle groups. If we go back into the regulation and look at the B double table, at 40 tonnes, it'll say we need about 9.2 metres minimum to achieve 40 tonnes.
Mm-hmm. And that's just all this is spread loads over the bridges.
If this example was a road train, we'd obviously use the road train table in the MDL regulation.
And the other thing is using those tables, if you don't have the distance required for the mass, you can actually reduce your masses to still comply.
Yeah. So yeah, we'll go into an example about that, but what Kerry's trying to say is if you wanted 40 tonne on the rear trailer, for example, and the minimum was 9.2, and you didn't have 9.2, you could reduce your mass potentially maybe 1 tonne off here or 1 tonne off here, to still comply with the table.
Yes.
But we'll show you an example on the next few slides. You want to go to the next one?
Yeah. Next one. So here's a road train, example of road train or a PBS level 3A double. So general mass limits up the top there, 6 tonne on a steer, 16 on a tandem, 20 on a tri, 16.5 on a tandem, 20 on the tri, total 79 tonne. So we go each axle, so axle 1 to axle 3, so axle groups 1 to 2. Some of the axle mass is 22.5. So the thing in brackets is the actual, with the 2 values there, one outside the brackets is actually comes from table 4, which is the road train table in the mass dimension loading regs. And the value in the brackets is actually applying ASMS, so the actual formula rather than the tabulated value, which is what is used in the performance-based standards tier 1 assessments. So under the table I can have 2.5, under the axle spacing max schedule I can have 3.33. However, as we discussed before, there's a minimum of 3.5 metres, 2.5 metres between axle groups, plus 1 metre between your axles. So there's a minimum of 3.5 there, but not controlled by your bridge formula or your ASMS. So the next one we look at is from axle 1 to axle 6, so axle groups 1 to 3. We've got 42.5 tonne, and both the tables and ASMS say we need 10 metres. The next one's axle group 1 to 8. Well, axles 1 to 8, so 1, 2, 3, 4, so we're up to the next tandem axle group. So axle groups 1 to 4, 59 tonne, so we need 15.5, and they're all in agreement. So next one is axle 1 to axle 11, which is axle groups 1 to 5. So this is the overall axle spacing of the vehicle. To get your 79 tonne needs 22.2 metres. So then we go to your drive group, which is your second axle group. So axle 2 to axle 6, 8 metres. Axle 2 drive group to the last of the first dolly, 2 to 8. So the axle groups 2 to 4. We got 53 tonne, so it's 13.5 metres required. 2 to 11 is to the rearmost axle, 73 tonne, so 20.2. 4 to 8, so we're now going from the first to your trailer axles, of the lead trailer axles. So axle 4 to axle 8, axle groups 3 to 4, 36.5, 8 metres again. And the next one's axle group 4 to your rearmost axle is 56.5 tonne, 14.7 metres is required. And the last one is you go from, you're basically getting the last trailer, so axle 7, axle 11, groups 4 to 5, 36.5 metres, 8 metres is the minimum requirement. So as I said before, assessment is at GML masses without MDL mass exemptions, and you may reduce axle masses to remain compliant with shorter spacing. As an example here, if if my axle group 1 to 6 was only 8 metres rather than 10 metres that required, I can get 36.5 tonne on it. So what I could do is actually reduce the mass of my drive and the mass on my first trailer axles down by 6 tonnes. So I might run 13.5 tonne on the drive, 17 tonne on the first trailer with a shorter trailer, and I would still comply with the requirements. All right, so we work. Okay, and we'll do PBSA double axle masses. What you can actually do there, and we'll show on the next slide. What they do there, they may be compliant with the road train formula or the PBS levels 3 and 4 formula.
Yep.
But if they want to run it level 2, which means they're running based on the B double network, be suitable for the B double network, they can actually run at reduced masses. So next slide will show you how that works.
Yep, we go to the next one.
Yeah.
Yep.
This is actually taken out of a VA or a vehicle approval for a PBS vehicle. So we'll look at table 2 first. So what happens here, it's a level 2 vehicle. So it's equivalent to a B double in all its performance characteristics. In swept path, how much lane space it takes up, its dynamic performance, how it's performed. So it's been assessed dynamically and statically to meet the PBS level 2 standards. So it basically performs like a B double. But in this case, if you're fully loaded up, you're going to exceed the B double formula that we looked at, or the B double tables. So I want to run level 2. If we have a look at the table there, it says GML instead of being 79.5 tonnes, it's reduced to 70.65 tonne. And to achieve that, if we look at the table 2 at the top, we look at level 2, GML, we go down, you see the mass is 6.5, 16.5. The 6.5 is complying steer axle, which is actually added in later. 16.5, 20, 16.5, 20, but you have to refer to the other little table underneath that. So it's got limitations on how much mass you can have in the axle group. So it's looking at for axle group 2 to 4, which is your drive when you prime move that to your first. So it includes the drive, the triaxle group, and the first dolly. That's limited to 52.55 tonne, rather than, what's that, 6.5, rather than 56.5 tonne, which you can get, which you would be able to get if you had the full masses. And that's because the distance is too short to meet the B double requirements. And the same for from the drive to the rear of the trailer, 64.15 tonnes, and which is 40. So there's a reduction, which is reduction from about 73.5 tonnes there down to 64. And the last one's axle 3, last one's from the triaxle group on the first trailer to the end of the trailer, it's reduced to 53.35 tonnes rather than a maximum of 56.5 tonnes. So that's how you can have reduced axle masses
to meet the
bridge formula. So table 1, if you have a look down there, it's at the full masses that they're allowed. Now you'll notice that for GML, 79.5 tonne with the 6.5 tonne steer axle, CML and HVNL, which we discuss later. CML is you get increased axle masses, but there's rules in CML that say you can't have more than 2 tonne over the GML mass. HVNL, if you sum up the HVNL masses, it comes 85.5 tonne, but under the VA it's only allowed 85 tonne, and that's because in the PBS performance-based standards there's actually a horizontal pavement landing standard which doesn't exist for other vehicles, for regulation vehicles, but it says if I've got a tandem drive unit on my combination, the maximum mass I can have at level 2 is 85 tonnes, so that's why it's 85 tonne limit set in there. And the bridge assessment is tier 2-3, which means if it's tier 2-3, it means it doesn't meet the axle spacing mass schedule requirements. So this is at the higher masses. You know, that same vehicle could then run on the road train route at those masses and be compliant. But for level 2, which is B double, it's not compliant. So I know it's fairly complex, but that's the way it works. There's a whole pile of nothing is in isolation, like the actual mass spacing schedule is not in isolation from other requirements. Go next. Yep. So there's other MDL requirements which we just talked about. So there's requirements on height, width and length. So for general access, the maximum height is 4.3 metres. And then there's a number of vehicles being allowed higher than 4.3 up to 4.6, like stock crates, car carriers, things like that. However, they're restricted access vehicles. Yep. So the general rule is 4.35. Width is 2.6, excluding mirrors, signalling devices, and some road restraint.
Sorry, Terry, it's 2.5.
Did I say what did I say?
2.6.
Sorry, 2.5. They're looking at 2.6. 2.5, sorry, maximum width, and that excludes mirrors, signalling devices, and some road restraint devices. Maximum length for a normal rigid vehicle is 12.5 metres. For a combination vehicle, which could be a prime mover, semi-trailer, or say a truck and trailer, maximum length is 19 metres. So things like B doubles, they're allowed up to 26 metres, and road trains up to 53.5, but again, because they're over 19 metres, they're restricted access vehicles. So they have controlled access on where they go and what conditions operate. There's axle spacing requirements in the mass dimensional loading regs. So if you've got a tandem axle group, that's 2 axles. They link together as an axle group. Minimum 1 metre, maximum 2 metre spacing between the centres of the axles. For a triaxle group with 3 axles in a group, so it's greater than 2 metres and up to 3.2 metres. And a quad axle group is greater than 3 which is 4 axles, greater than 3.2 metres and up to 4.9 metres overall axle spacing. There's BXXY spacing rule, which controls the distance between your axle groups and the B double to look at controlling bridge loadings. Minimum 2.5 metres between any axle groups. It actually says in the law if it's less than 2.5 metres, the maximum gross vehicle mass or maximum mass of the vehicle loaded can be no more than 15 tonnes. So if you're a very short truck, it's restricted in its masses. Things like road train drawbar length has to be between 3 metres and 5 metres. And there's controls on quad axle groups over 20 tonne in the regulations, so for freight vehicles. So they have to go through the performance-based standard scheme. They have to have a steerable axle, at least one steerable axle. They have to have road-friendly suspension. They must be enrolled in massive maintenance management, and they're subject to individual or to route assessments. Next. Okay, and as I said before, everything's interlinked. They're all interlinked and everything. So this is looking at out-of-context use of the axle spacing mass schedule. So there was a review of ASMS, and these vehicles, the top 3 vehicles put up as critical vehicles as PBS level 3A or 36.5 metre road train, and they were critical vehicles for structures for those requirements. The problem is these vehicles, the top 3 vehicles, they all meet the axle mass spacing schedule. However, they're not realistic vehicles. So we'll discuss that a little bit. So if you look at the top vehicle, it's actually got 1.2 metre axle spacing. It's a prime mover, semi-trailer, towing 1, 2, 3, 4, 5, 6 single axle dog trailers. If you have a look at that first part, you've got a prime mover semi that's probably not much longer than a Toyota Hiace long wheelbase van, which look really funny sitting on the road. There's problems with it that, you know, with the 2.5 metre axle spacing, it would not meet the B double requirements for 3 metre drawbar lengths. The other big problem is with it, it's the more articulation points you have on all those, the more transfer movement you have, and yeah, they tend to just run down the road like a snake, wobbling all over the place. So and it's the same with the other 2. The one on the bottom is a standard 36.5 metre road train. Now, with the HVR, we're interested in productivity and safety as part of what's the last section. That's the objectives of the law, is looking into productivity and safety. The top 3 vehicles aren't productive, in that the more trailers you've got, especially the top one, the more tear weight you've got, less load carrying capacity you have for that vehicle. The other thing, they're purportedly level 3A vehicles, and which limit to 36.5 metres long, but they decided that to go to 42 metres, which is PBS level 3B, but that's 42 metre axle spacing, not 42 metre overall length. So as we talked before, the rear overhang, the front overhang take up some of that. So we had a look at these, and we've got some software, PBS assessment software. So we ran these vehicles through them, and this was the lane change test, which is what happened if it tried to change lanes. Because it's got so many articulation points, it's a very, very unstable vehicle. And so it actually rolled over when we did a modelling of it. So vehicles like this are not safe. Tracking ability in a straight line, and this is the tandem axle one, not the single axle one. We couldn't actually model that because the modelling software didn't allow that many trailers. So this would be better than the single axle one. Tracking ability, high speed, steady state off tracking, which basically measures if you go around the corner how much the rearmost trailer swings out into the next lane or off the line of the prime mover. So we're looking at a 1.4 metre rear swing out, so I would like to be coming around the corner If it's doing a left-hand turn, I wouldn't like to be coming the opposite way because the rear trailer's hitting 1.4 metres into my lane. So there's no way that that sort of vehicle will be allowed on the road for safety reasons. So the moral out of this is if you take things like ASMS in isolation without considering all the other requirements in the law, you need to sort of moderate theory. So theoretically it's a vehicle that can run under the meets ASMS. You need to moderate theory with a bit of reality and look at the whole story, not just one little small part of it. So that's the lesson out of that one. So what we'll go on now is in the mass commencement loading regs, there's things called mass exceptions. So these are added on after you've done your bridge formula calculations. So this is now no longer a mass exception, it is now included in the law as a general mass limit. So it's complying steer axle, so it was formerly a steer axle exception. But when you're doing your axle spacing mass schedule or you're using your bridge formula, you use a 6 tonne. So for vehicles fitted with front end, and this steer axle exception has probably been around for at least 20 years. When they first started bringing in low emission European engines, they then have to use the AdBlue tanks and additives to get them to run at low emission. Also included this was to put rollover protection in the cab for protection of the operator of the vehicle, and then front end run protection systems or FUP systems fitted to the front of the trucks for prime movers to protect occupants when a truck runs up the rear end of a car. So all these were safety and emission standards, so it was a concession given to them for the extra mass that will be put onto the steer axle by implementing this safety. So that again, this was agreed by all the ministers and implemented probably 20 years ago. So you put extra half tonne on the steer for a complying steer axle vehicle, and again it's additional to GML, CML, HML masses. We've got a table later that explains that. Okay, next. Concessional mass limits. They actually replaced weighing tolerances. Again, these have been around for probably well over 20 years as well. So concessional mass limits. Prior to concessional mass limits, there was weighing tolerances. So if the law said you could have 16.5 tonne, you wouldn't get breached until you were 17.2 tonnes. I haven't got the actual figures, but something like that. So there was actual tolerance on top of it. In fact, so I would say if it was a tonne on your tandem axle group, you didn't get breached till you went to 17.5 tonne. So whatever they found people were doing was loading up to that maximum mass. So if it said 16.5 and I knew I wouldn't get breached by 17.5, the operators were operating at 17.5 tonne. So what they changed to was a mass measurement adjustment, and it's site-specific weighing. So under the new mass measurement adjustment scheme, if I get weighed on a weigh bridge, a proper weigh bridge, there is no weighing tolerance at all. So of the mass that I would get weighed. If I get weighed on portable scales, depending on where I'm being weighed, there's a difference in how much the compliance officers take into account before they decide to do a breach or not. And that's all, there's a mass measurement adjustment that applies depending on your weighing. So it's related to that. So what happened is there was people in mass management accreditation who would then would have been disadvantaged. You know, mass management accreditation includes loading controls. You have onboard scales. You have some sort of weighing before you move. You have maintenance managers to make sure all your suspension and everything is kept in good condition so you don't cause damage to the road. So to allow for those people in mass management, who would have been disadvantaged by the introduction of the mass management adjustment, they allowed CML in there. So there's some controls on CML. So there's vehicle restrictions. So there's no class 1 vehicles, so no prime move, no low loaders and things like that, or cranes. No buses and no pig or track trailers were allowed in CML. And you get a tandem, so you've got to be mass management accreditation, so you can have accredited. Your tandem increases from 16.5 tonne to 17 tonnes. Your triaxle increases from 20 to 21 tonnes. There's a cap on your GCM or your GVM increase, so if you're under general mass limits, if you're up to 55 tonnes, you can get 1 tonne more. If you're under general mass limits, say like a road train by B double, and you're over 55 tonne GML, you get a maximum 2 tonne. But there is some jurisdictional anomalies by notice. For example, in Queensland, you can get 12 tonne on a twin steer under CML and up to an additional 4 tonne on a 53.5 metre road train.
So those limits on the slide there for tandem and tri, they're in the mass dimension loading national regulations.
Yeah.
Under a separate section, similar to the high mass limit, which is next.
Okay.
There are other notices out there that may give a little bit more specific vehicle types with conditions, which is what this dot point means.
So again, they're an exception and they're added on after you do your ASMS, your bridge formula at GML masses. Okay. So if we go to higher mass limits, so again, this is basically for fitting a road-friendly suspension because it reduces road wear and actually dynamic impacts on the road as well. So, so there's some vehicle restrictions. Again, there's no class 1 vehicles. You cannot have a truck and dog or a truck and tag, and you can't have triaxle drive groups except on road trains and B doubles. So you've got to have road-friendly suspension. You must have mass management accreditation if you're running triaxles. You have a single axle increase from 9 tonne to 10 tonne on buses. Tandem increase from 16.5 to 17 tonne. Triaxle increase from 20 to 25 tonne. And your GVM or GCM increase is by the sum of axles increases. So there's no cap like with CML. It's route specific operation, and normally on the HVNL network is what's allowed. And there's some jurisdictional anomalies again by notice. Victoria allows 10 tonne on a 4-tired single axle, which is under notice. And New South Wales and Queensland require that you have telematics, intelligent access program, so tracking of the vehicles. And again, these high mass limits are on top of GML, so they're additional. So the next page will show you how that works.
So just to summarise, if you have a double as an example, at GML, using the general mass limits of 6, 16.5, 20, 16.5 and 20, your GML limit would be 79.5. If we're eligible for a complying steer mass exception, you'd get that extra 0.5. So it's just applied on the top here, so it'd be 79.5. If we're running under CML, since this combination overall can go above 55 tonne, you're only allowed 2 tonnes. So you would just add 2 tonnes on top of your gross, which is where we get the 81 from.
Just on that, and that's not the sum of the axle mass increases, because if you add up that, you get half a tonne on each tandem and a tonne on each triaxle, which adds up to 3 tonne.
Yeah.
But
So by
CML capture 2 plus 2.
Yeah, that's right. So if you add all of the axle group masses here, you go above 81 tonne, but the rules of CML is you can only have 2 tonne extra. If we go to HML, there's no cap, so you just add the sum of axle group mass limits. So you get 85, and if you have the complying steer, you go to 85.5, the extra 5 tonne there. Do you want to go to the next example?
Yeah, we'll go to the next example. Okay, so if we include a truck and dog, so a truck and quad dog, or 3-axle truck with a 4-axle dog trailer, and compare that to a 7-axle B double. As a road manager, you should really, your main worry should be for your infrastructure will be the axles on the ground. So if you look at them, basically they're the same configuration, they should have the same effects on your bridges and pavements. Because of the different couplings, they've got, because the bottom vehicle has got 2 articulation points, it'll actually turn better, but it'll wobble more going down the road, where the B double is more stable, but it's got its swept path is at low speed is more than what a truck and dog would be. Yep. So under the MDL, or maximum 6.5 steer, 6.5 tandem, you can have a maximum of 6.5 on your trailer tandems, tandem axle groups, but you capped at a maximum of 42.5 tonne. Now if you're running under the general access under the MDL, you've got to have your trailer mass cannot be greater than your truck mass. So it's a 1-to-1 ratio. So that's only for the trailer and truck, it doesn't apply to the B double. If you're running under the notice, which allows you to run up to 50 tonne or 55 with complying steer axle, or 50.5 with complying steer axle, that's can have up to 16.5 on each of your tandems on your trailer, but there's a 1 to 1.25 ratio. If I'm running restricted access, I'm running under a, in this case, the B double notice or the PBS truck and dog notice with the 4-axle dog trailer. I'm not restricted to the 1-to-1 ratio, so I can get my full axle masses of 56 tonne. If I then want to run under CML or HML under that B double notice or the PBS truck and dog notice, I only have 17 tonnes on each one, and because my GML is over 55 tonnes, it's 56, I can then have a maximum of 2 tonne more. So it doesn't matter whether I'm CML or GML, CML or HML, I can get the same mass on those configurations under notice. Now the difference between, for the tandem axle group, if I'm operating CML, I have to have mass management accreditation, but I don't have to have, don't have to have road-friendly suspension, but it's most likely I probably will have to meet the standard to all those vehicles. And if I'm operating HML, I have road-friendly suspension, but I don't have to have mass management accreditation. It's just an anomaly of how CML and HML would implemented and developed under different circumstances. So I have the same maximum mass of the CML and HVNL for those vehicles. So now we're looking at access for these vehicles. So if I'm a truck and dog, 42.5 tonne, class 3 truck and dog notice, 50.5 tonne general access, and for a PBS level 1 truck and dog running under the level 1, you'll run on the PBS level 1 network, which should, from what we looked at before about the axle spacing mass schedule, should actually replicate, should be general access. Okay. PBS truck and dog, if I'm under 19, or maximum 19 metres long, I get general access at 42.5 tonne. I can run under class 3 truck and dog notice up to 19 metres with general access at 50.5 tonne. If I'm running under the PBS truck and dog notice, I keep PBS level 1 network, which should be general access at 50.5 tonne, and PBS level 2 access, which should be the B double network at 57.5 tonne.
So what this table pretty much shows is that for a truck and dog, for the truck and dog combination shown in the previous slide and a 7-axle B double, they're pretty common. The MDL will restrict them to 42.5 tonnes at general access, though there are notices out there that will allow them to go mostly up to 50 tonne and also 57.5 tonne depending on configuration.
So if I'm a B double, 42.5 tonne, so I've got the same axles on the ground. B double notice, I get general access at 50.5 tonne, and under B double notice, I can get 50 at 57.5 tonne. I can get the B double routes. If I'm a PBS B double, I get general access 42.5 tonne. General access 50.5 tonne under the B double notice, up to 90 metres long, and B double routes at 57.5 tonne for the same configuration. Alright, and there is no notice, there is no PBS B double notice. It'll run under the other. So the problem is if I've got a slightly different axle spacing or something like that, or I'm able, if say I'm 4.6 metres high and I've gone through PBS because I'm 4.6 metres high, I actually can't run on the B double routes unless because I exceed the 4.3 metres high. So I couldn't run under that notice at that time, so I'd have to have an individual permit, and hopefully I'd get all the B double routes because my only difference is my height.
If there's any questions about this particular table, be happy to send through more information or even send you the notices, what the vehicle should look like, and the differences in the states, if there is any.
Yep.
Do you want to move on to the PBS?
We'll go on to the next one. Yep. So as part of the HVNL management of performance-based standards vehicles, it actually calls up the PBS standards and rules, and this is actually taken directly out of that. So the performance-based standard actually has a bridge loading standard as one of its infrastructure standards. We saw a previous infrastructure standard on that horizontal pavement loading, and it says the purpose is to limit the maximum effect on a bridge so that to that which is acceptable to the bridge owner. Its intent is primarily to address risk to infrastructure, combat safety issue, if a structural component fails, or an amenity issue if access across a structure is restricted So these are the three things that a road manager has to look at: risk to infrastructure, risk to public safety, and risk to public amenity. The bridge loading standard addresses the issue of bridge strength and ensures that PBS vehicle does not induce effects on bridge structures that exceed accepted limits as specified by the bridge owner. Okay. So next graph. So there's 3 tiers in the PBS bridge loading standards. Now, do not confuse these with bridge assessment tiers, okay, because they've got very similar terminology. Tier 1 basically means it complies with the mass dimensional loading regs, the formulas that we use to develop those. So it complies with those axial spacing mass schedule tables, but it does it by the formula, but it actually uses the formula rather than use the tables in the MDL. But the effects, as we looked at before, are equivalent. Tier 2, so Tier 1 vehicle should get network access the same as the comparable vehicle in the MDL. So level 1 general access, level 2 PBS should be B double access network, and level 3 and 4 should be 36.5 metre and 53.5 metre road trains respectively, of course based on their bridge loading standard. Tier 2 is a special access, so it's limited network access. So basically you compare it with existing vehicles operating on the road and see how it compares with those. So it's a vehicle comparison, Tier 2, and Tier 3 is actually where you go into a proper bridge assessment and it'll be route specific. So it might be a specific link between networks or something like that.
Yep.
Okay.
The next few slides go into more depth what each of these tiers mean.
Yep. So if I'm going through PBS and I'm a PBS assessor, I'd apply the bridge formula for whatever level I'm operating at. And the bridge formula is the axial mass spacing mass schedule formula. If I pass that, if my axial spacings meet the requirements for all combinations of axial spacings, I pass them. So I do not need an assessment, a bridge assessment, to travel on the same network as the comparable prescriptive vehicle. So from level 1, I don't do a bridge assessment to travel on general access, level 2 B double network, level 3 and 4 on the respective road train networks. If I fail that, then I step up to the next tier of assessment. The first tier is vehicle assessment, comparison. One after that is proper bridge assessment.
And this only applies to PBS vehicles.
Yeah, so this year. So this is when you PBS, you look at the VA, if it says level 1, tier 1, there's no, or level 2, tier 2, or tier 1. So tier 1 are equivalent to respective prescriptive vehicles.
Yep.
Next. So the tier 1 bridge formula. So you use the term minimum length between axles, so it's exactly the same as we looked at before, applying the axial spacing mass schedule, always used with GML masses and the own bridge formulas for each level of access. So next.
And just to clarify, so if a new PBS vehicle comes in and is a vehicle approval, that is tier 1, it means that it complies with the tables and the bridge formula
for that level.
Which is what we showed at the start of the presentation.
Yeah, we showed earlier that we had this extract from a VA where it had table 1 and table 2. Table 2 was its PBS level 2 tier 1 So it's equivalent fix to a B double, so it should be used on B double network. So again, so PBS level 1 is MDL general access. Yeah, exactly what we did before. So you've seen that before. Now we'll go on and have a look at the next.
Yep. So the same formulas as the general access ones at the start of the presentation.
Yeah. So an example. So the distance between two groups is 7.5 metres. Maximum allowed mass across the two groups is 35 tonne.
Which is here.
If the distance between two is 15 metres, the maximum allowed is 47.5 tonne. So that's how easy it is. That's where you showed the examples before. So you just got to make sure your actual spacing is sufficient to get the mass that you require. PBS level 2, again, this is exactly the same graph as they use MDL table 3.
Yep.
Yeah. So B double, MDL B double.
Yep. And this is all, you do this check to see if you're tier 1 for the PBS vehicle.
Okay. And it's all done. You don't have to do anything as a road manager. It's all done for you as through the assessment. So a vehicle goes to the assessor, it gets assessed, it meets the performance standards. They also check against the bridge formula. And then that's checked again with the NHVR before the VA is issued or the DA is issued. So if it comes back and it says it's a tier 1 for that level, it's already been checked. You don't have to check it again. And next.
Yeah.
So level 3 and 4 is the same as the MDL road train tables. The only thing is because they can go longer up to 60 metres for the PBS level 4B, it'll actually, the table goes a little bit higher than the 172.5 tonne in the law.
Yep.
But I think you got to look at spans greater than 40 metres before it becomes an issue.
Yep.
And there's not a lot of those. I would expect to be a lot of those out in road train or type 2 road train areas.
Yep. Just to quickly clarify, there's a question here, Kerry.
Yep.
The previous slide, so the 46.5 tonne,
yes.
Is it gross mass?
Yes, well, it's the axle mass is set up to 46.5 tonne.
That 46.5 tonne is the gross mass of the axle groups that you're calculating
yes.
for.
Yeah.
So, it's for the individual axle groups, not just the entire.
It's every combination of axle groups.
So when you're doing that check on the individual axle groups, most of them, if it's only a steer and a drive, it's only 22.5. So you'd fall under that.
Yeah.
It'd fall under 46.5.
But if you're doing, say, an A double like we looked at, you have the 46.5 on the number of combinations of axles.
So if you're doing the check for an A double, for example, and there's six or so axle groups.
1, 2, 3, 5.
If when you're doing your check on the overall axle spacings, you would definitely be over 46.5 added up. So you'd use the next formula.
If you're using anything except the steer axle, you'd be over.
Yep.
So if you're anywhere we've got two tri groups, it'd be over.
Yep. So just to clarify, it's the mass limits in these formulas are for the axle group you're working on.
Yeah, the combination of axle groups, and so they apply all the way through.
Yep. We'll go to the next one.
Okay, so the next level up from the PBS Tier 1 bridge assessment. So it says bridge effects note, so it's a vehicle comparison. So it's bridge effects notes worse than those caused by a reference vehicle, done by a pre-qualified engineer, and you should get access or the same access that you would give to the reference vehicle. It's up to the road manager to determine an acceptable bridge assessment method. So, and then tier 3 is individual assessment. So, going to the next one. So, we subject PBS vehicle versus a reference vehicle. So, you do what's called a comparative assessment, a MERV analysis, maybe. And the reference vehicles might be Australia's Bridge Assessment Group, your ABAG vehicles, which are used for network design. Existing vehicles, you might have an existing vehicle or vehicle combination operating on a specific route that they're asking for, or across a specific bridge. What you might want to do is compare the effects with that existing vehicle, or maybe a prescriptive vehicle.
Yeah, so this would be in the instance where a VA, there's a vehicle approval that comes in and it has tier 2 on the vehicle approval, which means that it didn't meet the bridge formula as we mentioned before. So it is recommended to do this type of assessment, which is seeing the effects with an existing vehicle or a comparable vehicle.
Yeah. One thing to consider is with a lot of these vehicles, they're related to a particular freight task. So you may have some commodity that needs to be moved. The reason they're probably putting on a PBS vehicle is to replace the existing vehicles. So just because you've got different type of vehicle coming in doesn't mean you're going to have a whole pile of more vehicles. You look at the vehicles that's most suitable to do the freight task. So if I've got a quarry, say, and I've got to get 50,000 tonnes a year out of it, I can do it in wheelbarrows, I can do it in road trains. One's a lot more effective. So that's just because it's a new vehicle doing the same freight task, it does mean the freight task is going to magically increase it.
We'll show an example on what this may look like.
Sorry,
tier 2 example, yeah.
All right, so these are some of the ABAG vehicles that they use for bridge assessment. So what we've done, we've used the ABAG B double. We'll go into it when we do it. Yep. So you do a comparative assessment, so compare shear force, bending moment, reaction forces caused by the reference vehicles with those of your subject vehicle that you want to use. So there are different positions of the vehicles on bridges that vary in span lengths, and they're normally 100 mil chunks they take out, and it plots the ratio of the impacts. So you'll have the baseline will be 0, which is the impacts of the reference vehicle, and the subject vehicle will be recorded as over and above that line.
So
if we look at what we're looking at, so your bending moment on a single span, so the more mass you've got towards the centre of the span, you have maximum bending effect. The shears, your forces through the ends of the beams, ends of your things. Individual spans, sorry. And then if you've got multiple spans, like a contiguous structure, you get both positive and negative bending. So sagging and hogging, as it's called.
So for this example, we've compared an 85-tonne, first graph, an 85-tonne PBS 30-metre A double, which is tier 2, 3.
Tier 2.
So obviously the vehicle didn't comply with the bridge formula, so we've compared it against one of the ABAG off-road vehicles we showed before.
Yes, the ABAG B double, so B double with 6 on the steer, 17 tonne on the drive, 22.5 tonne underneath the triaxle groups, and then we compared it with this 85 tonne 30-metre A double as shown there, running at HVNL masses. we started having issues at about 4 metres. Do you want to use the issues with hogging at about 4 metres it starts? So the grey one? Yeah, about 4 metres it crosses the yellow line, so it then it goes up to about 20% more hogging effect there, and then it drops down and goes back up again to about 25% at around 30 metres. The next thing is your peer reaction at about 5 metres, and it kicks up to about 18% overload. It never gets down below the line again, and goes up about 25%, around 40, 50 metres. You got your sagging. It's not too bad until about 18 metres, and then you start to kick over up to a maximum about 15% overload. Your abutments, again, around about 18 metres, and it kicks up to about 13, about 13% or so. Your peer reactions, they take off fairly quickly. So what can we do about that? So one thing you can do, you can reduce the masses on the vehicle. Now, looking at that, at the top graph, the fact that you've got those two reactions at short spans over there would suggest that your problem is your centered axle groups. So your triaxle group and your tandem axle dolly, because they're very close spaced, so they're causing some issues at the start there. So what we can do, we can say, well, we'll run them at reduced masses. So we'll go down to 15 tonne on the drive, 20 tonne on the triaxle groups, 15 tonne on tandems, and we get this result here. So if in that case, if you're happy with 5% overload on hogging and about 4% overload on peer, and because it doesn't cross that line again to about 17 metres or so, if my span length I'm looking at less than 17 metres and I'm happy with that small overload at the start, I can probably allow that vehicle at those reduced masses. Okay, so if we go to the next one, as we talked about previously, it's that centre group with that triaxle. So if we reduce the triaxle mass to 18 tonne and the tandem axle mass to 15 tonne, we can actually, now we've got a 74 tonne 30 metre A double, I'm actually drop that early sagging, hogging and peer reactions down. Again, about 18 metres, your hogging starts to cross again. So I've got short spans under 18 metres, I'd be quite happy to use that vehicle.
At a reduced mass.
At reduced masses, yeah, as comparable. And so we can do that compared to that vehicle. So we may have a 68 tonne, 26, an A-bag HVNL B double already using that route. So we can say we're happy for this vehicle to operate on that route where there's spans less than 18 metres. In the bottom one, what we've done there, we've actually said, well, we took 2 tonne off the first triaxle group because it caused the problem. We'll put that on the rear triaxle group and we get 22 tonne. So again, we've controlled that hogging, early hogging, and again, we've got hogging again about 18 metres. So the actual overall effects of those two vehicles is very much the same, even though the bottom one's actually weighs 2 tonne more than the top one. So the general Tier 2 bridge assessment, we use a reference vehicle. So the actions caused by the application vehicle are less than those caused by the reference vehicle. So we went back to our first example where we went the 76 tonne.
Yep.
Yep. where it was over. We're not happy with that operating. So here the reference vehicle's effect in bending in that case is down there. The B double application, or the A double application we looked at, has got greater bending moment, so we're not happy with the Tier 2 assessment. So we say, no, we won't let that vehicle run. We will now do a Tier 3 assessment. So next slide. So when we do a Tier 3 bridge assessment, it's approved by the owners of the bridge to use all bridges specific link. So it's undertaken by the bridge owner. Each bridge in a specified route will be assessed against the PBS vehicle, and it's not automated, it's a fairly lengthy process. So this is where we actually get into proper bridge assessments, not just comparisons. So that's where road managers will need to actually look into detailed assessment of the structure. And so next page. In this case, we've done our bridge assessment. So through capacity of the bridge. So we looked at the ultimate capacity of the bridge and we compared it with the application vehicle. For the example here is for bending moment. And from that we can see the actual bridge strength is greater than the bending moment caused by that particular vehicle, and therefore you'd be happy to allow access to that route based on that.
Yep.
But so it's a three-step process. So Tier 1, it should be getting network access for the same vehicle, same type of vehicle. Tier 2, you compare it with existing vehicles or a reference vehicle. And Tier 3 is you do full bridge assessment. And as I said, please don't mix them up with the tiers they use in bridge assessment. Because I think, yeah, so which are different in each state, some have Tier 0. So, okay.
Yeah, I mean, this is the last slide, so if there's any questions, feel free to submit them. We'll definitely circulate these slides. There's some technical information in them, so feel free to contact us directly. There are a few questions here which I might just go through. One of them is, where can I find additional information on FUPS?
We can send that off to you. We'll have a just someone looked in the room and then left the door open, which was nice. The information on applying Xerox is on our website. We can send you a link to that. But it has to be an approved FUPS front under and protective system. It's not just a bull bar that they throw on the front.
Another one here, to clarify, the mass limits of the MDL are based on the ASMS?
They're based on the 1994 review, the Osprey's paper AP 113/94.
So let me I'll reference that.
And ensuing work that went. But the MDL, all those tables were included in previous heavy vehicle legislation in all the jurisdictions.
Yep. That reference to the 1994 report, I'll include it in the resources.
Yeah.
Just see here. Another one. In instances where a vehicle is considered acceptable under Tier 3 assessment, would conditions be added to the notice or permit, which requires, sorry, it's moving fast, which requires a bridge to only be crossed when no other vehicles are using the bridge?
You can include a condition like that. It's how you manage that is from the issue.
Yeah. So
whether you require them to stop, So you can, on your Tier 3 assessment, put other conditions in there, but you've just got to have a look how they're managed. If it's a busy road, or you may put stop signs up. So it's a way of managing the condition. The condition itself is a reasonable condition. It's how you manage that condition would be the issue.
If a permit shows that tier 2 or 3 is required for the PBS vehicle, and is it up to the road manager to determine the appropriate assessment type? Is it up to the road manager to undertake the assessment at their own cost during the permit review process?
Okay. It's up to the legislation or the PBS rules don't tell you what to use, but if it's tier 2, 3, the first thing you do would be your comparative assessment. And there's, under the HVNL, you've got the power, if you require assessment to be done, you go back and say, we need an assessment done on this structure. Here's the estimated cost. That can then be sent off to send in the NHVR, they can send it off to the operator, and then if the operator agrees to have it done, it's up to them to, it's then a financial transaction between the road manager and the operator, and if the operator doesn't want to get it done, then that's basically the end of the case. There's provisions in the law for road managers to undertake route assessments or assessments and to recover reasonable costs for those.
This one's more about road managers having the resources to undertake these bridge assessments. Are you aware of any, if there are some road managers that are having issues doing these, is there anywhere they can get support?
We do have the SLAG project, underway SLAG project.
Yep.
Which is, we've got a later session talking about that and a bridge assessment. So assisted with that,
I think we'll look into that one.
We'll look into that one.
We'll get back to you directly. So what is the relationship between the specified bridge design, load limit, and these bridge assessments?
The specified bridge design would be, that would come into your tier 3 assessments where you start looking at actually the design standard of the bridge. So that's where the other ones are basically you're comparing it with vehicles that are allowed to use the structure now because they're on a network, which is your tier 1, or you're comparing it with existing vehicles that are using or crossing that structure, is tier 2. And then when you go into tier 3, which is basically a full bridge assessment, that's where you'd be looking into your design standards for your assess and the impacts of that vehicle against individual bridges.
We have culverts with a load limit of 33 tonne. Does this apply to the GCM or the axle spacing mass limit, depending on the span of the bridge or culvert?
Yeah, well, depending on what you call a culvert, because there's different definitions of culvert, but you only link, and when they worked out the mass on the culvert, how it was worked out, but generally culverts won't carry a full vehicle. So even a normal prime mover 70 is 19 metres long. So unless it's a very long culvert, you're not going to get that whole vehicle on there. So you're probably more looking at axle groups and possibly combinations of axle groups, maybe like when we looked at that A-double, you're looking at the tri-axle group at the rear and the tandem axle group at on the first of the dolly, where you might get 36.5 tonne on a shorter culvert. So you might be better off doing a MERV assessment on that. And then you can see what span lengths are affected and compare that with the span lengths of your spans of your culverts.
We've answered the majority of the questions. There are a few inquiries about access related issues.
Yep.
I'll get in touch with you directly about those ones. I think there's a note here. Department of Transport are doing some bridge assessment training. Sorry, that's the Victorian Department of Transport. They're doing some bridge assessment training, level 1, 2, and 3, for bridge inspection and the monitoring process. I think you could probably go to the Victorian Department of Transport website for information there if you need to. I think at this stage we might end the stream. If there's any questions, again, please email us directly. I'll send out the slides shortly, so if you want to have a better look, feel free to do so and contact us if you need some assistance. The next session is in 2 weeks, so the 3rd of March. That one's about PBS, so it's more about the PBS standards and how they were developed, its history, the processes, and
how they relate to prescriptive vehicles.
And the prescriptive vehicle performance. Is there anything else you want to add, Kerry, or anything?
No, just again, thank you for joining in. It's what we're basically trying to give some fairly high level stuff so you have a better understanding of what the requirements of the law are and how they're being developed and how they're being used, how they should be used.
But there is quite a bit of content in this presentation, so feel free to contact us if there's something specific on a slide that doesn't make sense, or there's a value there that doesn't really make sense either.
Yep.
Right. Well, thank you, everyone.
Thank you very much.
Thank you.